In this video, we're going to solve this radical equation as well, and notice that once again we have a cube root. However, we're not going to cube this right away because 2 is being multiplied to the cube root of x plus 1, and then we also have a 6 being added to that cube root. So we're going to go ahead and use inverse operations to move as much as we can away from the cube root to get it isolated before we cube it. So the first thing that I would do is we're going to go ahead and go over here to this positive 6 that's being added, and we're going to subtract it. So we do need to subtract it from both sides because right now it's adding. That zeroes it out on the left side, and 10 minus 6 is going to simply leave me with 4 on the right side of my equation. I'm going to bring down my equal sign, and I'm going to go ahead and bring down 2 times my cube root. So 2 times the cube root of x plus 1. Now the next thing I want to do is this: anytime we have a number, an integer, in front of a radical, it's being multiplied. So imagine that there's a dot right here. This is just multiplication. So to get rid of this 2 from the cube root, I'm simply going to divide it out on both sides. 2 going to 2 one time, and that just leaves me with the cube root itself on the left, and 2 are going to 4 2 times. That leaves me with 2. So now at this point we're ready to go ahead and cube both sides of the equation. That way we can get rid of our radical. Now, as we've seen in the earlier video, 2 cubed is really just going to be 8 because it's 2 times 2 times 2. And so I'm just simply going to write 8. And that's equal to, and since we cubed this, it got rid of the radical, and we're just going to bring down our radicand that was inside of there, which is x plus 1. Our next step is we're going to subtract 1 from both sides so we can isolate the x, and you end up with x is equal to 7. And that's the answer. So while it looks really complicated, as long as you use your inverse operations, it's not bad.